Hello everyone, I'm really happy to be here. This is my presentation that I'm going to talk about Wi-Fi Direct. First, a brief introduction of myself. My name is Andrés Blanco. I usually like to reverse perform network research and privacy, and I usually enjoy doing Wi-Fi research. And I'm not a native speaker, so if someone has a problem listening, please question at the end of the presentation. So what we're going to talk about here. So Wi-Fi Direct or Wi-Fi peer-to-peer is a specification that defines and facilitates the device-to-device connectivity based on 802.11 infrastructure mode. This specification was released in April 2010, and at that moment there were not so many devices that supported, so it's not really known by most people. But nowadays, Wi-Fi Alliance, that I'm going to talk about later, has 13,280 devices certified with this protocol. So a lot of devices have support for this, and I'm sure that we can find someone nearby. And who is the Wi-Fi Alliance? Well, the Wi-Fi Alliance is an organization that creates different Wi-Fi protocols, and they also promote the usage of Wi-Fi. And as you may see here, we have 4 different specifications that Wi-Fi Alliance released a couple of years ago. WPS, that most of us here on a security conference know that was a really bad decision. And Wi-Fi Display Hotspot 2.0, that this is a new one that many devices nowadays support, for example, Apple devices. And then Wi-Fi Direct, that is the one we are going to talk today. So why I decided to do this research? Well, I usually don't need too many reasons to look into 802.11 technologies, because I like Wi-Fi, and I like the idea of anyone being able to connect to a device or try to do something with the device with only being near to the device. Okay, we don't need any privilege. We don't need to be plugged into a cable. We just send some frames into the air, and someone there are going to process it. But here I put 3 reasons that motivate me to do this research, and is that this protocol extends the 802.11 attack surface. And what this means is that if your device supports this protocol, it's going to have some support on the firmware, on the kernel, and in user-line applications. So this extended opportunities for attackers to perform some type of attack on a device. There are a lot of out-of-scope notes on the specification that forces the vendors to implement some type of solution that they have to implement it as they like, or the way they find to make a solution for this. Because, for example, I'm going to mention some of them in next slides. And then the last reason is that we have 13,280 devices. So there are a lot of devices around that support this protocol, and I'm probably sure that not many people know about this protocol, and in fact there are a lot of devices that have built-in default support for this, and maybe they don't know about it. So the specification can be divided into four parts. We have the peer-to-peer discovery, the peer-to-peer group operations, power management, and managed peer-to-peer device operations. I'm going to specifically talk about these first 2. The third one is what not of my interest, because I thought that nothing about security can be related to power management. I know there are some type of attacks, but it was not my interest. And the fourth one is really interested, but I was not able to get a device that support this 4 part, so I was not able to do practical attacks or tests. So I didn't saw that. So we're going to start talking about what is infrastructure mode. So infrastructure mode is what we usually use Wi-Fi, or how we use it. Okay, here in this conference, we have access points that provide us access to a network, and us with different stations connect and associate to the network and use the network that the access point is providing to us. It's the most common mode. Usually we use this mode, and we don't play with others mode. But we have ad hoc, for example. Ad hoc is another mode that lets devices connect each other. Okay? These two modes are defined on 802.11 standard, and this one is really not common to see on devices. We don't see this type of mode used by devices in the wild. Okay? So this was a good idea to implement two devices to connect each other, but it didn't work. Vendors didn't implement it, and it's not being used. And that's where Wi-Fi Direct come into play. So Wi-Fi Alliance, they decided to make something similar to a dock, but without enhancing a dock, but using the infrastructure mode that I talked at the beginning. So how does this work is, as you can see here, this is really similar to the first graphic I showed, that we have an access point. In this case, it's called peer-to-peer group owner. Then we have the stations that in this case, they are called peer-to-peer clients. And finally, we have a peer-to-peer group, that is the network itself. So this is based, as I mentioned before, this protocol is based on infrastructure mode. The difference is that in this case, I put a printer there, but any of the peer-to-peer clients can take the peer-to-peer group owner role. Okay? This peer-to-peer group owner is acting like an access point. But who is going to be the access point or the peer-to-peer group owner is decided at some moment of the negotiation of this protocol. Okay? So any of these can take an access point role. So there are two key components in this specification that I think is really important and concerns security. Is that the first one is called peer-to-peer concurrent device. A peer-to-peer concurrent device can be connected as a station to a wireless network, and at the same time be a peer-to-peer group owner for other peer-to-peer devices to connect to him. So in this case, my printer is connected wirelessly to my network, and at the same time has another computer that is connected directly to the printer. And the other component that is really important is known as cross-connection. And what is cross-connection is, if your peer-to-peer group owner have support for cross-connection, it can let peer-to-peer clients to talk and communicate directly to peer-to-peer to stations and the access point itself. So you can use the printer as a bridge to connect to the devices, to the network the printer is using. So these two components are really important to take note, because we are going to talk later. There are some devices that they don't have a really good implementation. And then, because in the specification again, they say that how cross-connection is implemented is out of the scope of the specification, these type of things can happen if the vendor doesn't take a really good choice or a really good approach to make a solution for this. The printers nowadays have Wi-Fi, wire, they have a lot of supports. In this case, a printer can be connected through a wire, and you can say that if you're not using Wi-Fi, you don't care because your network is wired, so you are not in danger. But maybe if your printer supports peer-to-peer and someone is able to connect to your printer and support cross-connection, you could end up being able, the attacker could be able to connect and use your wired network. So these two components are really important. So now I'm going to start talking about the discovery. Okay? The discovery process. To start talking about peer-to-peer discovery, first I have to explain a little bit about how 802.11 discovery works. This is quite easy. Many people maybe know this, but I have to explain it to understand the following. But you have an access point, and the access point is sending beacon frames, transmitting beacon frames to the air. And the stations can process these beacon frames and identify and find a network. This is the method called passive scanning. Okay? Without the station being transmitting any frame, the station can detect different beacon frames from the different access points that are here, for example, and identify all the options that they have to connect to a network. Then we have the active scanning. Okay? The active scanning, the station sends pull request frames to a specific access point, or they can send broadcast access pull request frames, and then the access point that respond this frame, or once they process the pull request, they will send a pull response frame to the station with all the information of the network, so the client can decide if they want to connect or not to that network. In both cases, the network interface is sweeping through all the channels the card support to find all the access points they can connect to. Wi-Fi direct specification and the peer-to-peer group owner. Remember I mentioned that a peer-to-peer group owner is almost as the same as an access point? Well, the access point usually use the beacon frame to announce a network. Well, the peer-to-peer group owner is going to also use the beacon frame to announce the network. So this station that here it doesn't say peer-to-peer device is a normal station, just like any machine you can have here. It's going to be able to find the peer-to-peer group owner because it's the same as an access point. So if you sometimes saw a network that it says direct dash something, that is a peer-to-peer group owner. So if you have ever seen that, you already have some contact with peer-to-peer devices and the Wi-Fi direct specification. But there are devices that they are not being a peer-to-peer group owner. Remember that peer-to-peer group owners is the access point of Wi-Fi direct. Well, some devices, they don't have to be on a peer-to-peer group owner. They want to negotiate who is going to be the group owner. So there are devices that they are on different states. We have listen state and search state. So here you have two peer-to-peer devices, and one peer-to-peer device will send a pull request frame. The peer-to-peer device is going to process the frame that has to have certain specific characteristics to work. And then if this frame is a Wi-Fi direct search or scan, then the peer-to-peer device is going to send a pull response frame. The only thing here that is a little difficult to understand is that both devices are sweeping the channels at the same time. So sometimes it takes a little more time to discover a device because usually access points, they are fixed on a channel. They don't sweep. So in this case, they are going to sweep in channels and they try to find each other. So at one moment, one device is on the listen state and is waiting for pull request, and then it switches to an active state, to a search state, and it will send pull request frames so he can announce he's there to other peer-to-peer devices. So it's important to understand that to do this, we have to do active scanning. So passive scanning tools are not going to work for many peer-to-peer devices. So here is a pull request frame. We can see here that it's a broadcast. It has a destination address broadcast and a SSID broadcast. And we have here the SSID that has a wildcard. This wildcard is the Wi-Fi direct wildcard. And here we have WPS and peer-to-peer information elements. Information elements are containers that go inside management frames on 802.11 frames and contain information. In this case, these two information elements and the SSID are the characteristics peer-to-peer devices require to be able to find each other. Once the device that is listening receives this pull request frame, it will send this pull response frame. This pull response frame is directed only to the peer device that is searching, and it will have the SSID that has the peer-to-peer wildcard, the WPS and peer-to-peer information elements. And I was only putting this here just to show that one of it has a lot of different information inside the information element, but the peer-to-peer at one part, it has a device name. This is the device name that will identify this device. There is also a note in the specification. If someone after the talk wants to talk about the specification, I have a copy here of my bag, so I can show you. There are a lot of things that they are out of the scope of the specification. For example, peer-to-peer device name are not unique. So if you have two TVs that have the same name, you are not going to be able to identify what TV you want to connect. So in the specification, it says that maybe you should try several times to connect to the device until you find what you want. This is a specification of a protocol, not someone trying to cook something. And then we have the service discovery, okay? That is another functionality that peer-to-peer device has that is able to discover for a specific service. Let's say I want to find a peer-to-peer device that has printing functionality because I want to print something. So you can send some, in this case, they are action frames. They are also management frames. You can say send a service discovery query frame to a specific peer-to-peer device, and he's going to reply with a service discovery response frame. The interesting thing here is these frames are not encrypted because they are management frames, and we are not even associated or authenticated to the device because we are again talking about discovery part. Okay, so all this is unencrypted and cannot be encrypted. And the funny thing here is that the content of these action frames is usually a part of another protocol. So these action frames use UPnP, Universal Plug and Play, Bonjour, printer services, and different protocols that they have content inside these frames. So we can know what type of service someone is looking, okay? And if we know that, we can also say, okay, hi, I'm a printer, connect to me. So you can try to impersonate a device. But not also that. This depending on the implementation of this service discovery, these frames can be grabbed from here, like this portion of the frame can be taken, and the device is going to insert an IPv6 frame inside the device, okay, inside, like if someone is connected to him, and it will insert the protocol that he identified there. So depending on the implementation, this could be quite dangerous because we have some like permeability between the network that is authenticated and a device that is not authenticated, that could be even able to inject some type of frames inside the network. So I like to talk about theory, but it's fun, or it's better to talk about practical things, or yes, so I'm going to talk about how you can do all these things, that they are quite easy. The third thing is, if you know about network cards, wireless network cards, you should know this card is really cheap and it works really, really good. And it could be used to play around with Wi-Fi Direct protocol. So if you don't have that card and you want to know if you can, again, do things with Wi-Fi Direct, you should run this command on a Linux machine, and it will show a lot of information of your interface. And if the supported interface modes has peer-to-peer client and peer-to-peer group owner, you're going to be able to do Wi-Fi Direct attacks. But how you can interact with this protocol? Well, in Linux machines, you should use WPA supplicant. Okay, in most distribution, this has no built-in peer-to-peer support or Wi-Fi Direct support. They don't have it built in. So you should download the source code and build it yourself. It's quite easy. You should read the documentation. It's really easy. You don't need too much stuff to do it. Once you do that, you have to build a peer-to-peer configuration that is, again, really quick and really easy. I will show at the end of the conference. I'm releasing some tools and some examples. You can look in there. And here I'm running on WPA client, that is a client that connects to the supplicant. I'm running peer-to-peer find that will perform the discovery I mentioned before, and I give a 5 seconds timeout. As you can see here, I found I find 3 devices, 2 printers and one Samsung Smart TV. You can use also Android. Android has Wi-Fi Direct support from Android 4. So you can go to your Wi-Fi advanced configuration and you can use Wi-Fi Direct from there. It's quite easy, and you can connect to a printer with your phone and use all the printer's services. It's really easy to use. But you have a lot of limitations unless you start playing with the Android API, so you can do something about it. And then the last thing I want to mention is if you use tools like Kismet or you use tools as AeroDump, you're going to be able to see these devices. As I mentioned before, these are peer-to-peer group owners. So peer-to-peer group owners, you're going to be able to find them and also connect them because they support legacy devices. So you can connect the peer-to-peer group owners when the peer-to-peer group has been built. If there's no peer-to-peer group build, only peer-to-peer devices can connect each other. And this is a tool that, again, I'm going to put at the end of the slides. It's a tool I coded in Python that is able to execute the peer-to-peer discovery without requiring a specific card. If your card supports injection and monitor mode, you are going to be able to use this, and you will get a lot more information. Not only the capabilities and other information available here in the information elements, but also the WPS information, and you will get serial numbers or manufacturer and different things. So let's talk about group formation. As I mentioned, unless one device is already in a peer-to-peer group owner role, devices will try to find each other, and then they are going to form a peer-to-peer group. To form this group, we need to negotiate who is going to be the access point. Okay? So we have a three-way handshake here. We send the negotiation request frame, then we say the renegotiation response frame, and finally the confirm frame. In this frame, it's important to know that there are two important things that they are defined here. Who is going to be the access point? That the devices send a specific value on the frames that is the desire for them to be the access point. So they discuss that, and then they define what channel they are going to use, what channel they are going to be listening. So once they decided this, they say, okay, I'm going to be on channel 9. And then the peer-to-peer group owner is going to set his network interface on channel 9, and it's going to turn him into an access point. Once the peer-to-peer group owner has been defined, it will start sending beacon frames. And then any client, any station that has support for Wi-Fi 802.11 infrastructure mode is going to be able to use this device. The important here is the provisioning is how these devices share the credentials, how they authenticate each other. Well, in that case, they are going to use WPS. The protocol I mentioned before that was designed by Wi-Fi Alliance. That protocol has several issues. If you look in the internet, there's I think 2 or 3 years ago, there was some guy that discovered how to perform pin brute force attack, and it broke most of access point that had WPS support. So using WPS could be an issue in this case also. How we can monitor Wi-Fi Direct. As I mentioned before, devices are sweeping channel from channel, and if you want to get all the traffic from these peer-to-peer devices, even in the negotiation phase, you're going to be you need to support monitoring several channels at the same time. I'm not going to talk too much about how to do that, but it's important to know that sometimes putting like 12 or 15 or 20 USB cards is not going to work, so you should look for other solutions. But monitoring several channels at the same time is an important thing here when we are talking about peer-to-peer devices monitoring. So I'm going to talk about some attacks that I have here. First, I'm going to talk about HP printers. So HP printers that had support for Wi-Fi Direct, that if you go to the web page of HP, there are a lot of new models. I think 2 years from now, 2 years from now, sorry, 2 years back, they start releasing new models, and these models have Wi-Fi Direct support by default. So what's the issue of having Wi-Fi Direct by default? It's not an issue in itself. The problem is how they implement it. So this is the configuration of the printer. Wi-Fi Direct is enabled by default. And the issue here is this one. They have the printer, by default, it starts a peer-to-peer group. You don't need to look for a peer-to-peer device and start the negotiation and say, okay, printer, you're going to be the group owner. The printer, by default, is going to set a peer-to-peer group, and it's going to be the group owner, without any peer-to-peer client needed to do that. And then you have the connection method to automatic. The issue here is that when you have this in automatic, you have two issues. The first one is that the Wi-Fi Direct passphrase, that is the passphrase of the access point that the printer is providing, is 1, 2, 3, 4, 5, 6, 7, 8. That is the password. So anyone nearby can connect to the printer with any device, because, as I mentioned before, this is already a peer-to-peer group formation, a peer-to-peer group already formed by the printer. So any device. You don't need even to use a peer-to-peer device that, to connect to the printer. Once you are connected to the printer, you can print, you can scan, you can use, in fact, the web server that has no authentication, and you can disable firmware updates, set a proxy server for the printer, or even try to attack that nice attacks that they were released, I think, at the first part of the year or the last year, that you can attack the shed printer port, I think 9100, and you can try to read the memory of the printer to see what were they printing before we get access to the printer. That is the first problem. The second problem is that also a peer-to-peer device, when the automatic mode is enabled, any peer-to-peer device can connect directly with no authentication and no notification at all for the user. So maybe you have your printer there and someone is using it and you will never notice. Let's say you change the connection method because you say, okay, connection method automatic is really a bad choice. Let's change it to manual and use the generate button here to generate me a new. Well, here, apparently the implementation confused the Wi-Fi passphrase that is used on WPA and WPA2 with the PIN of WPS. The PIN of WPS is limited to 8 charts and only digits. The passphrase is not limited to that, it's limited to 64 characters. So every time you push generate or you change to manual, it will generate a really easy to crack passphrase for the network. So if you grab the handshake between the printer and a legitimate device, you're going to be able to crack this in 2 or 3 minutes with any computer. So it's really bad. So Samsung decided to do something similar, and Samsung printer has, and again, used by default, a network key that is limited to 8 characters and only digits. So again, if you grab the handshake, it's going to be really, really easy to crack the handshake and get access to the printer. Remember that this printer is providing the access point, so you will never notice something weird inside your network because no one is connecting to your network. It's someone connected to your printer directly, not going through your network. So any IDS, IPS, or anything else you have is not going to be able to detect this because this is another access point. This is similar to a rogue access point on a network. That is Wi-Fi Direct, more or less. And there's another good demonstration that I will show you now, that I put phishing for a printer because it's more or less like a phishing attack, because we know that usually people, when they work near printers or when they work, if you go to print something on your office and you go there, the printer is having LEDs everywhere and flashing, and where is my sheet of paper? I don't find my print shop. Where? And you start printing all the buttons and then something happens. So that is how printer works. In this case, oh sorry, I will show you. Here I have the WPA supplicant running here with my network interface, a peer-to-peer configuration file, the driver. Here I have the client. This is 3 different terminals. Wait, don't. And here I have a root terminal, so I can show you then what is going on. So I will run the peer-to-peer find to look for peer-to-peer devices. I will put 4 seconds timeout. And I'm able to find the printer there. So this is a Samsung printer. I will copy the peer-to-peer device address. That just as a note, the peer-to-peer device address is not the same as the peer. Remember when I talk about concurrent operations, that the printer can be connected into your wireless network and also provide a peer-to-peer group owner? The MAC address is different. So again, if you are looking for sometimes when we are looking for soft APs or rogue APs, we are gonna look for the same MAC address of the device we have connected to our network or something similar. Well, this is different, so sometimes it's hard to detect. So I'm gonna execute the peer-to-peer connect command with the peer-to-peer device address. Finally, I will set this to use the push button configuration. It is one of the methods that WPS provides to authenticate to a device. You can use push button configuration, you can use NFC if you are near a device that has an NFC tag, and you can use a PIN number. In this case, I'm going to use the push button configuration. And finally, I'm going to set this value to join. And that is because, as I mentioned before, the printer already have a peer-to-peer group owner, is a peer-to-peer group owner. So the peer-to-peer group is already built. So I have to join this peer-to-peer group. So I will run this. And then we start seeing what is going on in the printer. So this is my printer. I'm near the printer. And the printer is going to do this. It's going to start blinking this LED here. And it's hard to see here, but if you see here, the printer is going to start the motors and it's going to start making noise. So once I see the motor here and blinking all the LEDs, I say, what is going on with my printer? Or I don't know what is going on. But this button that says WPS, I don't know what this means, but it's flashing. So I had to push it because it's the thing I have to do. So I go there and push the button. Okay, it stopped doing noise, so this is good. I can still use my printer. And now I gave access to someone. Okay, someone has connected now directly to my printer. I'm going to show you here that I can not only ping the printer, but I can also use the services provided by the printer. Usually, all the implementations I saw, the same services that they are provided when the device is connected to a network are the same services that they are provided to the peer-to-peer device interface. So I'm going to execute an nmap just to see what I have or what options I have. I can see here I have JDirect and different services, and I have a TCP server, a web server. So I'm going to connect to the web server. So that's all. I can connect to the printer and use whatever I want. I can print with the printer, I can connect, I try to configure the printer, I can do anything. So the interesting thing here is, if you think of yourself, what would you do if you have a printer that is doing this crazy thing, noise and everything, like 5 times in a row, okay? 5 minutes, the printer is doing, and start letting LEDs all. You're going to say, what is going on with this printer? You're going to go there and press a button. So this is phishing with a printer, okay? So you start sending frame, and then someone near the printer is going to say, what is going on with this? I press this button. Oh, it stops. Great. I'll go back to my place. And that's all. So that is a phishing for a printer. The issue here, to understand what is going on, is that when you use push button configuration, the WPS specification mentions that a button that can be physical button or a virtual button is going to be displayed on both devices, and you have to click both devices to authenticate that the devices want to connect each other. In this case, you're going to brute force and send unlimited push button request to the printer until someone pushes the button and you get access to the printer. Once you got access to the printer, you have to chain another attack, exploit the printer to try to get access to a network or the network the printer is connected to. If not, you are going to try to attack the printer itself. So let's talk a little bit about smart TVs. This is Samsung Smart TVs. I know that I have some discussion with some guys because they told me most smart TVs do the same implementation as Samsung, but I only get access to Samsung TVs, and as an independent researcher, I'm not able to buy 10 different TVs. So this is a TV I have at home. I attack my own TV. That's all I can do. But apparently, the same issue is presented on a lot of different devices. So Samsung Smart TV has Wi-Fi direct support, again, by default. The difference with HP printers and Samsung printers is that here, the TV is not a peer-to-peer group. It doesn't build a peer-to-peer group by default. So if you go around with your computer using Kismet or any other monitoring tool such as AirDrop, Aerodump, or any other tool, you're not going to be able to find these TVs. This TV is going to be like as I mentioned before, in the listen state. The TV is waiting for a pull request specifically for a peer-to-peer device that is looking for a TV. So the TV is going to be silently there waiting for someone to find it. Once you find the TV has, again, another issue I mentioned on the first slide is the peer-to-peer specification didn't define how we can connect several times to the same peer-to-peer device without authenticating every time we want to connect to the device. So because that is out of the scope of the specification, Samsung decided to use a whitelist, blacklist scheme. So they have a multimedia device manager on your TV that usually nobody finds because it's like in the menu really hide. And once you have, for example, a tablet that was already connected to a TV once, it will say, okay, I will allow this tablet to connect several more times because the tablet was authenticated the first time. I now trust the tablet is a good person. Okay? So I will explain everything, and then finally I will explain what is the issue. The first time you try to connect with your device, you will have something like this. This appears on your screen. It will say, fake peer-to-peer device name is attempting to connect. Here is the real peer-to-peer device. It's attempting to connect your TV, and with your remote control, that is a really secure component that cannot be impersonated, never. The TV is going to be, the user of the TV owner is going to select allow or deny to give access to this device. Finally, when you already are in the whitelist, your device is going to be, every time you connect to the device, it's only going to show this, connecting to, and the device name. Okay? So what's the issue here is that they use MAC filtering. Okay? The way to authenticate the device that was once validated, that is a real device, and you trust on the device, you are using the MAC address of the device. That is really, really easy to modify your network to your MAC address. For example, my computer here, I can change the MAC address, wait so the device connects to the TV. I grab a frame, I say, okay, this is a frame of a valid client. I will set that to my computer. I disconnect the legit device, and then I connect to the device. And let's say, we come back here, let's say I change my device name, okay? Because maybe the guy, if he's seeing something like connecting to tablet, and he will say, okay, but my tablet is there, it's off, how it can be connected? Maybe he turns like something weird is going on, okay? So in this case, you can change the device name because it's not used on the whitelist, okay? So you can put something like connecting to, and you replace the device name for the internet. So your TV is going to show a message here that is connecting to the internet. So that is a really common. I will not get too paranoid if my TV is saying, okay, I'm connecting to the internet. Maybe something went wrong. I don't know, it's disconnected. So all this is really confusing for the client, and if the guy doesn't know what is going on, this will go by, and he never noticed that someone is using the TV. This way. Finally, I'm going to talk about WTV, Western Digital TV Live. That is the worst implementation I saw so far. But it's important to mention before I finish, the Smart TV has a lot of services, okay? So you can also use a lot of services with the TV once you are connected through peer-to-peer. This is the worst, but it affected me a lot because I bought this device a lot of years ago, and I use it in my house a lot, like 1 year, and I never noticed that this was a perfect bridge to someone to connect to my network, and I will never notice. And this device now is in the trash. I throw it away. But it's important to understand that the implementation here is really bad, and it changed with another attack, okay? again, every time we talk about Wi-Fi Direct, I only taking abusing of the protocol to get access to the device. How you exploit then to get access to the other network, it depends on the configuration. So once you connect to the Western Digital TV Live, you have a lot of services. You have Samba, for example. Samba will let you interact with the device and all the mass storage devices that are plugged to the device with read and write permission. So anyone can write anything on any device connected to the media center. It also has this port that has a proprietary protocol to use as remote control, so you can remote control the device and, for example, make him to navigate a specific website or do something like that. And also has a web server. The issue with the web server is that it has at least 1 or 2 remote code execution without authentication. So the chain attack here is I have the Western Digital TV plug on my computer, someone is going to connect, and then he's going to attack the web server or the Samba server, and he's going to write me some malware on my mass storage device, and I will then grab it and put it on my computer, or he's going to do something and he end up owning my network. So this was a really, really bad implementation of Wi-Fi Direct, enabled by default, and no authentication and no notification. So I can be looking in a movie and I will never notice someone is using my device to pivot and connect to my network. Finally, I want to talk a little bit about Android really quickly. This implementation now is working fine. On Android 4, that was the first implementation, it had some issues. But this is a good example of how complex is the implementation of a stack of a protocol. When you're talking about 802.11, you're talking about code on the firmware running on your network card. You have a kernel driver or kernel module or kernel extension, depending on your operation system. And then you have user space applications that they also are interacting with the wireless frames. In this case, we are going to talk about the WPA supplicant and how a frame that goes through all these layers ends up sending an invalid frame. This invalid frame ends up sending an invalid event to the under framework, and it will crash the device. So here we have the Android implementation on Android 4. This is quite old, but again, it's a really good example to show the complexity of a protocol and how you not only can attack bad implementations at a logic level, but also exploiting something below. So here, if we receive an event from the supplicant and it's malformed, it will throw this exception to the Wi-Fi monitor that is in another class. But nobody handled this event. Okay, nobody handled this exception. So an unhandled exception on Android that ends up sending to the Dalvik, it will end up like restarting the Dalvik machine. So only sending one frame to an Android device, a Wi-Fi direct frame, crashes the device. Okay, I will try to show a demo. So this is really quick. I have 3 different devices, 3 different network cards, 3 different kernels. But what happened? I sent a malformed frame. The Motorola was the first one to crash. Then it's going to crash the Cyanogen. Again, remember, it is only restarting the Dalvik VM. And finally, the Samsung tablet is going to be restarted. The important here, as you can see, is we are taking the last layer of the implementation, of the protocol implementation, and we're able to bypass firmware and kernel implementations. So, conclusions. Availability. So Wi-Fi Direct is there. Anyone can find it, anyone can use it. As you can see here, main vendors, they have bad implementations. Some of them refuse to fix them. They say that there is no dangerous because Wi-Fi, you have to be near to attack Wi-Fi. So it doesn't matter. For me, it's a problem. Then confusion. As we saw on the printer, And another implementation, Smart TV, user maybe he doesn't know what is going on. The printer get crazy, start making noises. I go, I press a button, stop making noises, I'm okay. But maybe you just give access to someone to your printer. Or maybe you just, someone is connecting and using your Smart TV because it's not clear how this is working and how to use it. Weakest link. If I send a printer brute force attack, I know someone is getting tired of the printer making noises, so he's gonna plug it out of the network or plug it out of the current, or he's gonna press the button. Something is gonna happen, but the printer is not gonna be making noises and flashing LEDs for hours. And finally, these devices can be a bridge to a secure network. So you can have the best IPS, the best IDS, you can have a really hard passphrase, you can be really, really worried about your wireless network, but then someone put a new printer on the office and you are in trouble. Okay? That was the WTB for me. 1 year exposed. Attack surface. Attack surface is again, every time a specification is applied to a new device, so my device has something new, this is a risk. Every time some new feature is added to your device, this has to be implemented at a firmware level, at a OS level, and a user LAN level. So you have a lot of layers to attack. And in fact, if you see this year, there were a lot of Broadcom vulnerabilities found by Project Zero and Nitai that presented at Black Hat USA. All these vulnerabilities were exploiting Broadcom firmware. Broadcom firmware has implemented Wi-Fi peer-to-peer. So again, this extends the attack and gives more opportunity to attackers to abuse or implementation. And finally, I start doing new research on Wi-Fi Direct, and I start seeing different components that they are putting inside embedded devices or IoT devices that has Wi-Fi Direct support. So I think that this is going to get bigger. It's not going to get smaller. So thank you everyone for listening to my presentation. I hope you like it. And here is a GitHub repository where I set some tools and I have more information. But if someone wants to see a live demo, I know that here in this place, there are a couple of Wi-Fi Direct devices. So I can show you a live demo or anything after the presentation, or if you have any questions, I will be happy to answer it. No question? Too confusing? Too quick?
So what is worst, Wi-Fi Direct or Bluetooth?
Or?
Bluetooth.
Bluetooth was remote code execution. So I will first turn Bluetooth out, and then I will turn off Wi-Fi Direct.
On how many devices could you actually use as a bridge from Wi-Fi Direct into the internal network without having to exploit anything further?
You should search for the cross connection that is a capability of the peer-to-peer group. I saw that there are some Sony TVs that has this enabled. So when you build a peer-to-peer group, you could use to connect without abusing or exploiting the TV in itself. But I only have a Samsung TV, and the devices I have doesn't have cross connection enabled. So to turn that on, I have to root the device or modify the implementation myself.
Maybe I didn't express myself clearly. On how many devices were you able to enter the network where the TV, for example, is connected by wire over Wi-Fi Direct? Was this possible at all?
I didn't have any device to try that.
Okay.
But again, it's not specified on the specification how to do that. So it's out of the scope. So as you saw on the Samsung Smart TV, they don't have a solution for the problem they have, and they implementing themselves something. It depends on the implementation. I haven't found a device that I could test on because I don't own it, but it depends on the implementation. I'm not. I can at this time 0 devices because I wasn't able to test it.
Hello, thank you for your talk. Are we merely talking about implementation flaws, or is there something wrong with the protocol as well?
No, I only saw implementation issues. I didn't see any flaw on the specification itself. I think that the flaw in the specification is leaving a lot of things out of scope, so the vendor have to make their own solutions, and sometimes they are reusing other things. For example, the WPS generation button that generates pins instead of passphrase, I think it's because they already have that functionality and they reuse it. So I think that it's more leaving so much things out of the scope. That is the issue with the specification itself.
Thank you.
Oh.
So after connecting to the Wi-Fi direct, connecting to the TV using Wi-Fi direct, what could you do? Like you just could transfer a file?
The first and easy thing you can do is put something in the screen, because you can mirror the screen. So you can use your device and mirror something on the screen. So you can take control of what is displaying on the screen. But that is not a really interesting attack for me, so you should start looking to other attacks. Again, this is only like a Wi-Fi direct. I'm not talking about exploiting the whole device and a chain attack. But again, there was some talk, I think this year, about a guy talking about Samsung Smart TVs, that he found several exploits on the TV once you are able to connect directly on the same network. So if you chain that with this, you are able to attack it remotely. You didn't have to be in the same network. Once you have connected for Wi-Fi direct, you're going to be able to exploit these vulnerabilities.
Hey, just a quick question. From the attacks that you exposed, the one that it's forcing the user or tricking the user to press the VPS button and so on, and the other one that you said that you were able to clone to capture the
Yes.
handshake and see the MAC address and cloning. Have you been able to reproduce this yourself?
I do it on my own TV with my own phone. Yes, you can do it, but you need a device to connect to the TV. So if in that case, if nobody is using the Wi-Fi direct functionality, you're not going to be able to exploit it, because you need a legitimate device in the whitelist. Okay, so in that case, you're not going to be able to exploit it if no one is using the service. It's like the same as it happens with Wi-Fi MAC filtering. I don't know, in the 90s, with people say, okay, I only set my MAC address on my network. Until you see the valid the device connecting to a network, you're not going to be able to connect to the device.
So, but hello? Okay. So basically, you're just hoping at the best for someone to actually grant you itself access to the network.
Yes, on the TV, you're waiting for someone to connect, yes.
And even for the VPS, you're still trying to, or waiting for someone to push the button, hey, I'm allowing you.
On that attacks,
have
yes.
you tried to like brute force the VPS or something like that?
No, I haven't. But this is something you could try, because it depends on the implementation again. The WPS implementation on access point has evolved a lot. And nowadays it's hard to do a pin brute force attack. It's supposed to be that in the specification it says that you cannot connect to a Wi-Fi direct device using a pin. This is really clarified on the specification. One of the things I wanted to test it, and I didn't have time, is to try to use a pin that is on my printer and try to use that pin to connect using Wi-Fi direct. If that is possible, you have another issue, because Samsung printers also has an NFC tag on the printer that has a pin in the NFC tag. So if you are able to decode how that is generated, or the WPS implementation is not really good and that doesn't prevent brute force attack, you're going to be able to do a pin brute force attack on a printer or a TV or anything. But it depends on how they implemented WPS. I haven't tested that. I hope it's good as the last access point implementations. Here, we have
Ping? Did you try also fuzzing? Or?
fuzzing.
Yeah.
I play a little bit, not too much. The last thing I was starting to do is fuzzing the service discovery because I was interested in seeing what goes on when I start sending like weird frames and if it's sending it to an internal service of the printer and some process running inside the printer. But I didn't have too much time to do that. But yes, it's something I really want to do, start fuzzing the implementations. Well, that's all. Thank you very much.